Hi friends, welcome back to another session on operating systems. Now in this session let us see the structure of operating system, various structures we have for the operating systems. The simplest structure is about the Microsoft Disk Operating System, very famously known as MS-DOS. So in that the bottom layer we have ROM, where the basic input output system, device drivers and all are put in that, and then other device drivers are there on the upper level. Then we have resident system programs, and finally we have application program. So that simple structure is for MS-DOS. Then we have layered structure for Unix like thing, where the innermost layer, that is the bottom one, is the hardware. Then we have layer 1, layer 2, layer 3 and so on. So the layer 1 will directly interact with the hardware, that is layer 0, whereas layer 2 has to interact with layer 1, and if layer 2 wants to interact with the hardware, then it has to interact via layer 1 only. So that hiding is provided, security is provided, so that the upper layers cannot directly interact with the hardware. Only layer 1 will have privilege to interact with the hardware. So if we seriously design the layer 1, then the protection and security issues can be very well taken up. So that's the advantage of working with a layered operating system. Then we have a microkernel operating system, which is used in Mac systems. So in this case what happens is we have a hardware, and on the hardware we have a microkernel, that is only the essential components of the operating system are put in that, and we have a microkernel, and on that separately various system programs are written, like application, IPC, the device drivers, Unix servers, file servers and all that, and these are interacted by the applications. So the applications have to interact to the various system softwares, and through system softwares only they can interact with the microkernel, and through microkernel only any interaction with the hardware is possible. So this we have a parallel possibility when we are working with a microkernel operating system. So we can have a separate path from the application via some application like device driver, then to the basic IPC, and then finally down to the hardware. So we can have multiple sessions working parallelly. But yes, there has to be something called scheduling, which ensures that any given time only one of them is active, all other things are inactive. And then we have modular, again that's a Linux version, where a core kernel is created, and then all other device drivers and other things are put as various modules. So depending on the situation, so at the basic level, when we switch on the machine, the core kernel will be loaded onto the memory and it starts working, and then depending on the situation, various modules are put on the memory, and whenever the process do not require any of these modules, then they can be just removed from the main memory, so that with the limited memory a lot more activities are possible. Say when we are working with file system, only then we interact with the file system module. So we need file system module onto the main memory only when we are working with the file system. If we are not working with file system, then this module is no more required on the memory, so that we can have limited space used at a maximum efficiency. So that's various structures we have for the operating system. Many issues to be discussed in this series, so keep watching. Thank you.